Hello everyone. Let's wait for 2 more minutes, then we'll start. Welcome everyone to the first class of Accelerator. My name is Priyesh and I will be taking your maths part. Okay. So, like in maths, basically it's online class. So what you have to do is you just have to focus on question practicing. Okay. I will share the notes with you in the respective group. Okay. So no need to write down any notes. Everything will be shared in the group. Just focus on practicing the question and the concept basically. Okay. And we will start. Okay. And after some classes, if you feel that we should go in that way or we should be like practicing this kind of thing, so you can share your feedback. We will change our strategy accordingly. Okay. So I'm sharing my screen. So today is the basic maths class. So you have studied most of the concept in the previous batch. Okay. So we will practice some good questions on that and we will revise the theory part. Okay. So first part is the algebraic identities. So whatever identities we are studying, so these identities should always be on your tips. Okay. It's like whenever someone wakes you up and ask any identity, you should be able to tell that identity because these are the most crucial part in the simplification of any question. Okay, so how we basically you can remember this is the identity I guess you are using from your childhood. So just there is a sign change when there is a minus sign in the 2ab term. Similarly, when a plus b whole cube. So some of you may remember like this, others may remember like a cube plus b cube plus 3a square b plus 3b square. So that is your choice in what way you have to remember. Just you need to be remember this identity whenever it is needed. That's it. This is important one. This helps in the factorization most of the time. A cube plus b cube. So when plus sign is there, we will first write a plus b and then a square plus b square. But here there is a change. When you are breaking a cube plus b cube, plus sign will come with ab. Sorry, minus sign will come with ab. But when you are trying a cube minus b cube, so plus sign will come with ab. This identity we generally use only in this form, three variables, a plus b plus c whole square. but this identity is very helpful when you need the product of two variables at a time, this thing. So now see, when you are doing a plus b plus c whole square, all the variable square is coming plus 2 times of product of two variables at a time. So similarly, if you want to do a plus b plus c plus d whole square, every variable square will come plus 2 times of product of two variables at a time. So a into b, a into c, a into d. So first pair up a variable with all the other variables, then start with b. So b and c, b and d. Okay, so you should know how to pair up. We don't randomly write, we don't generally randomly write this. So always make a pattern and then you can write, so you won't make any kind of mistake. So this thing we need in some of the questions. Suppose there are 5 variables. Okay, so suppose you need AB, AC, AD, like this. So you should use this formula a plus b plus c plus d plus e whole square. So this is very important from its extension point of view, right? And sometimes we write like this also in short form, summation a square plus 2 times of summation ab, because you cannot write this lengthy thing again and again, so we write in this short form. So what is this symbol means? Summation a square means whatever variables you have, right? So you have to add square of each variable. In the same way, whatever variables you have to take product of two variables at a time and make all the possible pairs. Yes, any confusion in this thing? Anyone? Okay. Second, this is not frequently used, but it is easy to remember, so we will take it as in this thing. So same thing, a plus b plus c whole cube. So first cube of individual numbers. Now you should remember in this format. Okay, sum of two at a time. Okay, and the most important one is this. So here we have basically two conditions in this. First condition, if a plus b plus c is 0. Second condition, if all of them are equal. So if a plus b plus c is 0, RHS will become 0. If all of them are equal, then this thing will become 0. So in both the cases, your identity becomes, and this is super important in good questions. Okay. Yes. Any confusion in this, anyone? This factorization is also very important. This you will see very rare, but whenever this factorization comes, the question will be of good level. Okay. So a to the power 4 plus a square plus 1. So you can break into a square plus a plus 1 and a square minus a plus 1. Okay. And the proof is simple. What you have to basically do is, if I add a square and subtract a square, so this will become like this. If I add a square, so it becomes 2a square, and I am subtracting like this. So this becomes what? A square plus 1 whole square, and this is a square. So now this thing will become a square minus b square, right? So a minus b and a plus b. So you will get this form. So even if you forgot the factorization, because this is sometimes confusing of plus minus, So you can instantaneously factorize it. Yes. Any doubt in this, anyone? Okay. There are some useful manipulation. If you have AB plus BC plus CA, so you can write this thing as per your requirement as ABC 1 upon A 1 upon B plus 1 upon C. You can see when you multiply this and this, BC will be there. Similarly, AC will be there. Okay. Second manipulation is this one. Okay. So this thing can be written as half times of this. So this is easy to derive. Just multiply and divide by 2 in the LHS. So this becomes 2A square, right? So now just break this A square into A square plus A square, B square plus B square, and C square plus C square. So pair one A square and one B square, and then pair it up with minus 2AB. In the same way, pair one B square and C square, and one square is left, one C square is left. So you will get your respective perfect squares. Okay, and in this we have one more factorization, A square minus B square. Okay, try this, factorize this, and everyone should answer in the chat box. Okay, so no one else will disturb with the answers. Whatever is your answer, you should answer in the chat. Okay. Last 1 minute, then
So
we'll
one
discuss.
minute, sir, I'm just typing it.
Yeah, yeah. Also, what you can do is if someone has answered it and the answer is in very long format and you got the same answer, so you can write it same as Soham and okay. Okay, so we have two options here. Either you can convert it into a form of a cube minus b cube or a square minus b square. So a square minus b square is the more easier form. So let's convert it into a square minus b square. So this become a minus b and a plus b. So finally these two we very well know. So a minus b and second one is a plus b, right? Yes. Anyone have doubt in this? Any step? Okay. Second one, since there is no direct identity we can apply in all of this, so what we can do is we can break it into two parts. So here it is 2x square and 3y square, and when we take 3 common here, this also becomes 2x and 3y form. So first part will give you a minus b into a plus b. So we got one factor common out of this. So this is the final factorization. Yes. Any doubt in this, anyone? Okay, try this. Last 2 minutes. Okay, so no identity is directly applicable in this. Okay, and so what we can observe from here is this is a perfect cube and this is also a perfect cube. So let's separate this perfect cubes, right? So if we have a two cubes, then this resembles our identity of a cube plus b cube plus c cube minus 3abc, right? So there is no c cube and there is no 3abc. So let's try to convert, okay, this 5a cube into third cube and 3abc term. So if I take out only a cube out of this and then I write 4a cube, so this becomes a cube plus b cube plus c cube, but this is not representing the 3abc thing. So see, you have to do this thing like this step by step. Okay, so this is the incorrect one. So next thing what we can do is, because we need perfect cube, so I can break like this also, minus a cube plus 6a cube. Minus a cube is also perfect square. So if we break like this, so a cube plus b cube plus c cube. Now this is my c, and I can write this 6a cube like this, 3a into b into c. These are the ABC. Yes. Any doubts here in this, anyone? So now you have the complete form. So we can write like this: a plus b plus c, a square plus b square plus c square. Okay, minus ab minus b into c, but c is negative this time, so it becomes plus minus c into a. So this becomes plus 2a cube. So just simplify the like terms here. Yes. So you have to do some trial and error approach to convert this thing. Okay, in good question, everything does not directly come to you in step by step. Yes. Any doubts in this? Anyone? Any step? Any calculation part? Okay, try this. Yes. Is anyone asking something?
No, sir.
Okay, try this. Last minute. Okay, so we have just seen the manipulation for this part. This can be written like this. So if we write half times of, so shift that 2 on the RHS, so this inequality will become. So here, this is a very beautiful concept, and they can, good questions and good competitive exams use this concept. Okay, so they have given the sum of the squares of three numbers. Let's say this is x, y, and z. So square of any number is either 0 or positive. So sum of the squares of three numbers cannot be 0. So the only possibility left is the sum of the squares of the three number is 0. And if the sum of the squares of three numbers are 0, then every number should be 0. So from that, a, b, and c are equal. So just change everything into a. So 2a upon a is 2. Okay, so this is very important concept. They sometimes give you the perfect square in the inequality form. Okay, now see, there are three variables, so you basically need three equation to solve it. And there is only one condition, it means that we cannot individually find the variable. Okay, so we have to use some hidden conditions into this. Yes, any confusion, any doubt in this, anyone? Okay, for this question, don't go with the method where you directly put the x equal to 1 plus root 2, find its individual power. This question is not made for that kind of method. Okay, think some smarter approach. Last minute. Okay, so this method which I'm going to share is for every kind of like polynomial. If it is a 10-degree polynomial, then also you can use that method. Okay. So first thing is, if this root 2 is not there, then how easy it would be. X equal to 1, just substitute and find the value. So we first try to take care of this root thing. Okay. And the same method will be used when you have given some complex number. Okay, just suppose 1 plus 2 iota. Iota represents the imaginary part in the complex number. So that kind of questions, when you study in the complex number chapter, you can use that same concept that time also. So what we are doing is, we are shifting the non-root term on one side and root term will be on the other side. Now let's square both the sides. So this become a square plus b square minus 2ab. So basically x equal to 1 plus root 2 is the root of this equation. Clear? Now we try to create this quadratic expression in these terms so that we can use the value of this quadratic expression 0 here. So how we do that, that is very important. Okay, so everyone observe carefully. Just picking one term at a time. Okay, in the first step we start with the higher power. So now x to the power 4 can be written as x square into x square, but we need this whole quadratic to use this 0 thing. So what we are doing is, I'm taking this whole quadratic, but if I do like this, so I am getting x to the power 4 x square into x square, but we are getting these extra term also. So in order to balance these extra terms, what you have to do, x square minus 2x is minus 2x cube, so we have to add plus 2x cube. X square into minus 1 is minus x square, so we have to add plus x square. So we have taken care of the first term, just write the rest of the terms as it is. So this is exactly the same expression as this. We just manipulated the x to the power 4 like this. The rest of the part is exactly same. Yes, anyone have doubt in this manipulation? Because after this we have to just repeat this thing again and again. So now this part becomes 0. So let's simplify this. 2x cube minus x cube will be x cube, x square minus 3x plus 1. Now let's reduce this x cube. So x cube can be written as x into x square. Now same quantity, balance out the extra terms. So and write down the remaining terms. This part again becomes 0. So we got x square minus 2x plus 1, right? Now, now you cannot again apply this same concept because you already reached the lowest power here. So you just have to now use this quadratic. So x square minus 2x value is 1. So just substitute 1. Okay. So this manipulation is very helpful. So just keep in mind. Yes. Anyone have any doubt in this? Okay. Harit, you also answered it correctly. So, like, do you have any shorter approach than this, or how did you do this?
No, sir, I just misread my handwriting, so I put zero instead.
Oh, okay. Okay. So, okay. Is this method clear to everyone? Okay. Now, again, same thing. This is very complicated equation. Okay. So, don't think of cross multiplying it and solving. This is not the way to solve this kind of question. So in complex kind of expression equation, try to figure out some pattern. There will always be some pattern which will directly simplify your situation. So just try figure out the pattern and solve. Last minute. Soham, did you get x equal to 0 by solving or just by trial and error approach?
Sir, trial and error because it's like minus 3 by 3 on one side and 3 by minus 3 on other.
Yeah, yeah. Okay. Okay, so this x equal to 0 also, I will focus on one important thing. Okay, so see. So we can observe this. Whatever written is here, the negative of the same is written here. In the same way, whatever is written here, the negative of the same thing is written here, right? So if for a moment I assume this thing as some alpha and this thing as a beta. Okay, this is also very smart approach of solving, assuming the things. Okay, since you figure out the pattern, but students generally go with the direct solving the pattern, and that makes it complicated. Always solve simple things, so we avoid silly mistake, our calculation becomes fast, so our time will be saved. So if I write like this, so now the question becomes 3x to the power 4 plus alpha, 3x to the power 4 minus alpha. Similarly, this thing becomes 5x to the power 4 plus beta. Now this question becomes this question of ratios. If two ratios are equal, so we can apply the componendo and dividendo. Anyone have doubt in componendo dividendo? Should I apply directly or like someone wants to recall it? Okay. So componendo and dividendo says numerator plus denominator, numerator minus denominator. Same here, and 2 beta. So now what happens generally here is also, now there is a very tricky part here. When you see same thing on both the sides, now we cancel out each other. But now we have grown up. So when you cancel something, now you are basically cancelling the solution. For example, there is an equation x square equal to x. So till now what we are doing is there are 2x on both the sides. Let's cancel out 1x on both the sides. So x equal to 1 is the answer. But when you cancel both the sides, now you have cancelled this solution x equal to 0, because x equal to 0 is also satisfying this equation. So from now onwards, don't cancel the things when we are talking about the number of solutions. Okay, what you have to do is just cancel out the number parts. Okay, and then what you can do is 3, 5, take out sorry, take everything on the same side and take out the common part. Okay, so you are taking x to the power 4 common. So 3 upon alpha minus 5 upon beta equal to 0. So first option is either x is 0, x to the power 4 is 0, so x is 0, or 3 upon alpha minus 5 upon beta is 0. Now here comes one more checkpoint. Okay, since you are taking x equal to 0 and alpha and beta also consist of x, suppose here there is no 3, so your alpha will be only this x square minus 2x. So if you are choosing x equal to 0, it means your alpha denominator is becoming 0 that time. When you substitute x equal to 0, your denominator will become 0 here also. But in maths, denominator 0 is not defined. So that time you have to reject x equal to 0. But since here by taking x equal to 0, alpha is not becoming 0, that's why we can take this thing as a solution. Now we have to just simplify this thing. So this is basically your 3 beta equals to 5 alpha. Now who is beta? 2x square minus 7x plus 3, and who is the alpha? X square minus 2x minus 3. So 6x square minus 5x square, 21x minus, and here minus 10x. So it will become minus 11x, and 9 plus 15, 24. So this is factorizable into x minus 3 and x minus 8 directly. So we got three values: 0, x equal to 3 and x equal to 8. Okay, so question is easy, but there are various checkpoints. Very common mistake which most of the students will do. If suppose they ask how many values of x satisfies this equation, okay, so and if you are going like this, so you will cancel out one solution, so you will answer only two value satisfies, right? So be careful whenever they ask about number of values, number of solution. Okay, yes, any doubt in this, anyone, any step, any manipulation? Okay, now there are some this special factorization. Okay, so I will show you this one. Okay, so you can try the next question. So when, see, this is a particular format, four brackets of x will be multiplied, right? Now what we have to do is we have to look for a particular pattern. And what pattern is that? See, we cannot multiply all the four brackets, neither we can multiply any three brackets. What we have to do, we have to make pair of two brackets. So which two brackets pair will be beneficial for us? So that's what, how we decide. See, we decide that thing by sum of the constant terms. First checking is sum of the constant terms. Here the sum of the constant term will be 5 when you multiply these two brackets, and when you multiply these two brackets, here also the sum. Okay, sum means we are not multiplying and then finding the sum, we are directly just finding the sum here, 1 plus 4. Okay, so 1 plus 4 5, and here also 2 plus 3 5. So we will make the pair like this, x plus 1 with x plus 4 and x plus 2 with x plus 3. Now see what happens when you multiply these two brackets. It becomes x square plus 5x plus 4, and here it becomes x square plus 5x plus 6. So that 5 which we have checked initially is basically this 5, right? So now if I assume this thing as a t, let's say this thing is a t, so it becomes t plus 4 into t plus 6. It becomes much more easier now. So this becomes quadratic, t square plus 10t, 24 minus 8, 16. Okay, so now this factorizes into t plus 2 into t plus 8. So first is t equal to minus 2, and we have t as x square minus 5x. Second we have t equals to minus 8, so x square minus 5x plus 8 equal to 0. Now always solving, before solving the quadratic, check its discriminant. Okay, so here the discriminant is greater than 0. B square 25 minus 4ac, 4 to the 8, positive. But here if you check the discriminant, it will comes out to be less than 0. B square 25 minus 4ac minus 32, so d is less than 0 here. So there will be no solution from this quadratic, so we will get only solution from this quadratic. Okay, so the solution will be minus b, since it is not factorizable, so use quadratic formula, b square minus 4ac upon 2a. So these are the two values which will satisfy this. Yes, any doubt here in this? So basically what we have to look for is this thing. When you multiply the two brackets now, this first two terms of the two brackets must be same, so you can assume it as a t and make a new quadratic. That's it. So sometimes even if the sum of these numbers will not come out to be same, focus on checking this thing basically. If it directly comes out that yeah 5 and 5, so you will directly get your pair. But in the next question, like here, if you pick any two numbers, okay, and you check the sum, now this thing is basically written as 4x plus 0, so no two coefficients are coming out to be same, so you have to focus on making this thing same. Yes, Any doubts in this, anyone? Because next question is on you.
Yes.
Okay, so try this. Last minute. So now here the constant thing fails. So what we do is we check the multiplication of the first two terms. So if you take these two terms, so 8x square will be there and here 2x square will be there. So these two will not be same. So we can clearly see if we multiply these two and these two, then we will get the first two terms same. So 4x into x plus 1 and so 4x square plus 4x, and here it becomes 4x square plus 4x minus 3. This is t, so t into t minus 3, so 9 and 6. So t equals to 9 means 4x square plus 4x equals to 9, and 4x square plus 4x equal to minus 6, right? So let's write in this form so we can easily find the discriminant. So here discriminant will be 0, b square 16 minus 4ac, 16 6 are 96, so d is less than 0. Here d is greater than 0, so x will be minus b plus minus b square minus 4ac. So 4 will cancel out, minus 1 plus minus root 10 upon 2. Yes, no one answered it. So, like, any difficulty in manipulation or like any doubts here?
No.
So,
Okay,
so could you increase your mic volume so you're not very audible?
is it? See, my mic volume is full. Am I audible now properly? What
Yes.
about others? Are you able? Are you like not able to listen me properly?
No, so it's too faint.
Sir, it's little feeble.
Sorry, the last one I'm not able to get it. What about hello?
Yes, I know it's audible.
Okay. Yeah, just let me know any whenever you face any technical issues, just let me know. Okay. Okay, so this is second type of factorization. Okay. So here first thing is it is a degree 4 polynomial and every power of x must be present. It's not like that x cube must be missing out or x must be missing out. Every power will be present in the like descending order 3, 2, 1, 0. Second thing, first term and last term will be same as in the constant parts. Similarly, second term and second last term constants will be same. Okay, then only we can apply this thing. So how do we solve this? Divide the whole equation by x square. Okay, the middle one, and so it becomes 12x square, and this 12 divided by x square will become 12 upon, right? Similarly, minus 56x, and when this divided by x square, it becomes minus 56 by x and 89. So now when you take this 12 common, it becomes x square plus 1 upon x square minus 56 common. So now just we have to convert this thing into a x plus 1 upon x whole square. So what we have to do is a square plus b square. So we have to add 2ab and balance out 2ab. So now this part will become x plus 1 upon x whole square, and 12 minus this will become minus 56. So I guess everyone can see a quadratic in x plus 1 upon x. If we assume this thing as a t, so our quadratic is 12t square minus 56t, and 24 minus 89 will be 65. Okay. Try to factorize this and find the value of x. See, whatever you get t as a, you have to equate that t with x plus 1 upon x. Okay, then solve it again. So just factorize this and find x. Let me know what are the values of x you are getting. Now just find x, so your t is correct. Okay, so everyone, you will get t as this, and when you substitute t equal to x plus 1 upon x, you will get two quadratics. Okay, so you will get these values of x. Okay, so you can verify that. And this one is for homework. So try this in the homework. Okay, answer will be given below. Exactly same pattern. Okay. Yes, anyone have doubt in this? Any step, any concept? Okay. Next is the basic exponent laws and exponential equations. So I guess exponential laws everyone very well aware. Any number to the power 0 is 1 except the number should not be 0 itself. Okay. And if the numbers has same base, powers will add. If the number has same base and they are in divide, powers will subtract. This bracket is very important. Okay. A, M, N. Okay. So this bracket represents that the power is in the multiplication, right? If you directly write like this, so it means that M is in the power of M. Okay. So there is a difference. So always use bracket whenever you are simplifying things. Any number to the power negative can be written like this. Now this qth root of a to the power p. So you can write like this, a to the power p by q. Qth root means 1 upon q power. Okay. Here the important thing is that q will always be a natural number and greater than equal to 2. Because if q is 1, there is no 1th root of any number. Okay. Root starts from square root. Two numbers, you can multiply them. Two numbers in the divide and they have the same power basically. This is the power of nth root. So you can combine and write in a this way. If there are multiple roots, so either you can multiply the powers or you can interchange the powers as per your requirement. Now this is important one. Two numbers are in the root. So when you can write root a into b, because every time you cannot write like this. So let's have a very basic example. Root 2 into root 3. So root 6. Now if there is a negative sign in the root, okay. So whenever there is a negative sign in the root, it becomes imaginary number basically. Have you studied anything related to imaginary number ever before?
Yes.
Yes, sir.
Okay, so you are like familiar with the word iota, right?
Yes, sir.
Yes.
Okay. Okay, so here when you are multiplying these two, you can write minus 6 root. Okay, so these two are the correct ones. But if you have both the negative numbers, right? Now from here we have two options to simplify. First, I can directly multiply these two. So minus 2 into minus 3 is plus 6. Second, I can write this thing as root 2 iota into root 3 iota. I'm taking out minus 1 root from both the sides. So it becomes root 2 iota, root 3 iota. So after simplifying this, this becomes root 6 and iota square will give you minus 1. So as per the maths, this is not possible that if you are multiplying two same numbers, so you are getting two different products. Okay. So when the numbers are imaginary, right? So this product will be considered as a correct one. This one is the incorrect one. So this product rule is only valid when both the numbers are positive or at least one of the number is positive. But if both the numbers are negative, then you cannot directly write a into b. For that, you have to write minus ab. Okay. So this is for future reference. You will study this thing in the 11th class in the complex number chapter. Okay. but since it is coming out here, so I am explaining this thing. Yes, any doubt here in this, anyone? Okay. Now in the exponential equation, we have various types of exponential equation. Okay. First one is when the base is same and the powers are different. So the possibilities what we have is if your base is not 1, not -1, not 0. So true, these two will only be equal when the powers will be equal. Suppose here written as 2 to the power 5 equal to 2 to the power y. So this will become equal only when y equal to 5. But if the base is 1, so 1 to the power anything will always be equal. 1 to the power 3 will equal to be 1 to the power 7. So x and y can be any real number. It is not necessary x and y must be same. If a is -1, okay, now in case of -1, we have to be careful because suppose -1 to the power 3 and here -1 to the power 6. So this will become +1. This is -1, so they won't be equal. So either the powers will be on both the sides even or odd so that the sign will hold. And if the base is 0, so 0 to the power any number except 0, any positive real number will be 0. If why we are not taking negative real number, suppose -2, then it will become 1 upon 0 to the power 2. 0 goes in the denominator, which is not possible. So any positive real numbers will be the solution if this is the scenario. So everything depends upon what kind of base you have. Yes, any confusion in this? So you don't need to remember this, okay? When you see the question, you will automatically able to analyze it. When the bases are different but powers are same, so the possibilities is suppose the base is not same, okay, the numbers are not same, then power must be 0. If suppose you have 2 to the power something equals to 3 to the power something, so 3 to the power any number will never be equal to 2 to the power any number. This is only possible when the powers will be 0. Now if the bases are equal and not 0, so x can be any real number. If the base is here 2 to the power x equal to 2 to the power x, so x can be any real number, it will always be true. If a is equal to -b, so now you have -b to the power x and b to the power x. Then here b to the power x is a positive quantity. So here also it must be a positive quantity, so x must be even, otherwise this will become negative. So x is a even number. And if both are 0, then x can be any positive real number. Now if both the base are different, both the powers are different. So this you can only solve by taking log on both the sides. Suppose they have given 2 to the power x equals to 5 to the power y. So just take log on both the sides with respect to any base you want. Okay, let's take log with respect to base 2 on both the sides. So here it becomes x equals to y times of. So this is the relation base. But since we are taking log on both the sides, both the numbers must be positive. Okay. And the numbers are not equal because if numbers are equal, then it becomes the first case. Right. Now this one is also important. When you have a functions of x, basically powers, like this example, okay, you have powers as well as base as a function of x. So we have four possibility for which these two will be equal to each other. If the base becomes 1, so if the base is 1, 1 to the power anything will always be 1, so true. If base becomes -1 both the side, but for -1 the powers must be of same type, either both must be even, both must be odd. Okay, that we have seen why it should be either even or odd. Or base becomes 0, So 0 to the power any positive number will be 0. Or gx and hx are equal, the powers are equal, then automatically this equation will hold. But for these two cases, -1 and 0, verification needed, or there is a checkpoint. So we will see why there is a checkpoint in the example. Now here, just read this example, then we will do it. Okay, so we have to find the sum of all the real values of x. So first thing, the base will be 1. If this is 1, so 1 to the power anything will always be 1. So case first, x square minus 5x plus 5 is 1. So when you solve this, we got x equal to 1 and 4. So when the base is 1, no verification is needed. Second case, if the base is -1, so what do you think? What should be the nature of the power of -1? So you will get 1. Anyone? If base is -1, if this is -1, so what should be the nature of power to get 1?
So it should be even.
It should be even. So that is the checkpoint. When you solve this equation now, whatever values you are getting, you have to substitute those values in the power and check are the power becoming even for that value or not. So x square minus 5x plus 6 equal to 0. So this becomes, now checking the power thing. So x is 1. So power will become 1 plus 4 minus 60. So minus 56. The power is becoming odd. Okay, so we cannot take this 1 as a solution. Similarly, if x is 6, so 6 square plus 24, everything is even, so power will become even. So only this is acceptable. Yes, any doubt in this verification which I mentioned?
No, sir.
Okay. Now this third thing is not valid here, that fx becomes 0. If this becomes 0, then there is no point of 1 here. So we won't check this thing. Last part, if the power becomes 0, if power becomes 0, right? So when power becomes 0, base should be non-zero, right? That is what we have to always check. So see, case third, when power is 0, so any number to the power 0 will be 1. So this becomes x minus 6, right? So x is minus 10 and 6. Now we have to check whether minus 10 or 6 is making this thing 0 or not. So x equal to minus 10. So 100 plus 50 plus 5 not equal to 0. X equal to 6. Again not equal to 0. Both values are acceptable. So total values of x, the sum, case 1 values, case 2 and case 3 values. So case 1 we got 1 and 4. From case 2 we got only 6. And from case 3 we got minus 10 and 6. So 6, 4, 10 directly cancels out. So yes, any doubt here in this, anyone? And just check everything once in the last. So here we have done the incorrect factorization. Minus 5x will not be formed here. Minus 6x minus x. It's x minus 3 and x minus 2. We have to check for 3 and 2. So when it is 3, then 9, 12, 60. So even and odd will give you odd. And here it is acceptable. Okay. Here when you check, this thing is 0. So both are acceptable. So here in the second case, we have only 2. Okay. So 4 and 6 cancels out. This minus 10. So only 2 and 1 is left. Yes. Any doubts here in this, anyone? Try this. Last minute. Okay, so if the power is written like this, 3 to the power 2x, 12 can be written as 3 to the power x and 4 to the power x, and 16 is basically 4 to the power 2x. So basically we have 4 and 3 powers here. Okay. So see the middle term splitting method, we generally study in the quadratic, but the method is not limited to quadratic chapter because it never says middle term splitting of quadratic only. Middle term splitting means if you have three terms, if you can split the middle term in such a way that you will get the product of the first and last term, the method is applicable. So you can see if I break this term into two parts, so each part will have 3 to the power x and 4 to the power x. So when you multiply those two parts, you will get 3 to the power 2x and 4 to the power 2x. Suppose a quadratic is like this. Now this is not the actual quadratic, but you can apply the middle term splitting because if you break the middle part like this, so the product of the two middle part is coming out to be the product of first and last term. So same is applicable here. Okay. So we have to break this thing. So what we have is 27 and 64. 64 means 6 twos and 27 means 3 threes. So now we have to make two numbers out of these which can be like solve. You will get minus 84 and the product will automatically become this. So it's obvious that if you select all the three, right? So let's first select all the three. So 27 into 2, 54, 54 and 32. So it's not 84. Now, if I select all the threes and two twos, so 27 and 4, 108. But now 108, you have to subtract then. 108 minus 16 will give you positive 1, or minus 108 plus 16 will give you negative 1, but not 84. So let's pick only two threes. So 9, okay, and or we can write like 16 threes are 48 and 36. and the last is this. So from here we can take 36 and 64. Okay, so we can take 4 common, so here 9 and 16 will be left, and there is 3 to the power x common also. So 16 into 3 to the power x minus 9 into 4 to the power x. Now same bracket will appear here. So just directly write this. Now what should be multiplied with this? So you will get this part. 16 3s are 48 and 4 to the power x. So it factorizes into, so first from here you will get 3 by 4x equals to 3 by 4. Here you will get 3 by 4x equals to 9 by 16. So x is, okay. See, you can make it in simplified form by, let's say, divide this whole thing by 3 to the power x. So this becomes 3 to the power x. This becomes 4 upon 3 to the power x. Sorry, divide by 3 to the power 2x. So this completely got removed. This got cancelled out, and 1 3 to the power x will be here. 3 to the power 2x will be here. So it becomes quadratic in 4 by 3 to the power 2x. Then also you can solve it. Okay. If you find it difficult to judge this thing directly, you can solve it that way also. Yes. Any doubt here in this, anyone? Okay. Try this. This is on the basic exponential laws. Last minute. Okay, so first convert it into a all prime factors form. Here it becomes 2 to the power minus 4 by 3. So here 2 to the power 1 and 1 plus 1 by 5, 6 by 5. Okay, 3 to the power 1 by 3. Here 5 to the power 2 by 5. That becomes 5 to the power minus 2 by 5. Here, so minus 4 by 3 plus 6 by 5. So 20 and 18. Minus 20 plus 18. So we have this also now. When you simplify this thing, 18 and 5, 23 by 15. And 5 does not have anything, so same 3 to the power 1 upon 3. So this becomes 2 to the power 6 by 5, 1 by 3 divided by. Now, this power will add up here. So taking LCM, 20 and 3, 3 by 5. So 3 by 15 and 5 to the power minus 7 by 5. So 3 to the power directly cancels out. So 2 to the power 6 by 5 minus 3 by 15. So 18 minus 3, right? 15 by 15. And this also becomes 1. Yes, any doubts here in this? Nobody answered this. Where everyone got stuck? Okay, try this. Last question of today's class. Okay, we just have to find out how many values of x will satisfy this. Okay, no need to find the actual value of x. Last minute. Okay, this looks like a 4-degree polynomial which we have studied. Whatever is the coefficient here, same constant term, same. Okay. So what we can do is let's assume e to the power 2x as a t. So this will exactly look like t to the power 4 t cube. Now just divide everything with t square. So t square plus 1 upon t square minus t minus 1 upon t and minus 3 equal to 0. So this becomes t plus 1 upon t whole square minus 2. Uh, So this becomes a quadratic of t plus 1 upon t whole square. Now, since it is not factorizable, so apply the quadratic formula minus b plus minus b square minus 4ac. So now t plus 1 upon t is 1 plus root 21 by 2 and 1 minus root 21 by 2. Now t is your e to the power 2x and e to the power 2x is a positive quantity, right? So this value got rejected. Also, any number plus its reciprocal, you have studied this in the AMGM. Any number and its reciprocal, if the numbers are positive, will be greater than equal to 2. So is this value greater than equal to 2? Then we will have a solution. So root 21 is 4 point something. So this becomes 5 point something divided by 2, more than 2. So solution is possible. So now this is a quadratic. Okay. And this thing is equal to some positive quantity which is greater than 2. So there is some value of x possible. So quadratic always has two roots. So this will have two solutions. Okay, and since it is not a perfect square, so definitely it will have two solutions. Yes, everyone. Any doubt in this? Okay, so that's it for today. Okay. Thank you everyone for joining.
Thank you,
Bye,
sir.
sir. Thank you, sir.
Thank you,
Okay,
sir.
bye.